Hello and welcome to our second transport unit, Unit 3B, Transport as Respiration. So we've just finished or are finishing Unit 3A, Transport, which is the circulatory system, and now we're going to look at respiration. So again, we're studying these units and systems separately, but you realize hopefully by now that every system is interconnected. So we study them separately, but you're going to realize to understand respiration, you have to understand the circulatory system because the circulatory system and respiratory system overlap and are interconnected. So it is a very short 1 week unit, I think 3 lesson 1 week unit, which unfortunately you're doing mainly at home on your own, while when you're in class you're finishing up the circulatory system unit with me. But it's very short, very simple, very easy. And again, I did post on our teams, there were a couple labs to go with this unit, but because of COVID protocol and the third wave here, a lot of those labs involve exhaling, obviously, which is a little bit of a high-risk situation right now. I know that sounds silly. 2 years ago, that sounds silly that blowing up a balloon is a high-risk situation. But that's where we are with things, but that's okay. We can deal with it. Okay, so our respiration unit. So today's an introduction to it. So respiration, there's actually 2 different types of respiration. The first one, I'm going to go ahead, we've actually already studied cellular respiration. So we've studied that unit 1, cellular respiration. That's when you produce energy for cells. That requires oxygen. So oxygen's taken into the cells and then they release and produce carbon dioxide. That was all unit 1. I don't know if you can see the bottom, but it is on your notes. Remember the glycolysis Krebs cycle? We talked about how cells get their energy from the food you eat. It comes in, gets broken down, and one of the byproducts is carbon dioxide. So we've already studied cellular respiration unit 1. So this unit, we're going to focus on the other type of respiration, breathing. That's where you inhale and exhale air. So that's the respiration we will focus on for this unit because we've already covered cellular respiration extensively. So breathing. One of the terms we'll learn first is a diaphragm. There's that silent G, so make sure you spell that correctly, diaphragm. And again, the diagram of the diaphragm shows that pretty well. I like this diagram. It's shaped like a parachute. So it's this thin muscle that separates the thoracic from the abdominal cavity. So thoracic is everything above the diaphragm, and then abdominal is anything below. And you made your diagrams of the digestive system, so you should have a good idea of the thoracic and abdominal cavities in the organs that line each of them. And the note at the bottom, lung tissue is flexible and elastic, and that's going to be important for the mechanics of breathing that we're going to go through. So this chart, it's pretty simple, and it's also, you can feel it, right? So for your test that you have, you shouldn't have to memorize when you breathe in, breathe out. You actually can physically feel some of these things happening in your body. So we're gonna run through, but if you breathe in, breathe out, you can model some of that on your own. And I know not everyone took Chemistry 30S, but those of you that did, remember we talked about Boyle's Law, and I did show a video in Chem 30S about Boyle's Law and how Boyle's Law is connected to our inspiration, expiration. So a lot of this is going to be volume pressure dependent, which if you took Chemistry 30S, Boyle's Law. Well, if you took Boyle's Law, we know that volume and pressure, it's an inverse relationship. When you increase volume, you decrease pressure, decrease volume, increase pressure. Okay, here we go. So inspiration, when you breathe in, so taking a breath, what happens? The ribs, you can actually feel the ribs. Your ribs move up and out. The diaphragm, you probably can't feel the diaphragm moving, but as your ribs move up and out, the diaphragm moves down and flattens. So what happens? Your ribs move out, diaphragm moves down. What happened to the volume? You've created a larger volume. The ribs are out, diaphragm down, larger volume. Boyle's Law, larger volume means lower pressure. And this whole breathing in and out is all based on equalizing pressure. So because you have a larger volume, the pressure decreases. So to equalize that pressure, air is going to rush in. So your body does Boyle's Law on its own automatically. Every time you breathe in, breathe out, that is all happening within your body. So even if you didn't take Chemistry 30S, well, your body knows Boyle's Law. That's what happens when you breathe in. That's all inspiration. Then expiration would basically be the opposite. When you breathe out, your ribs go down and in. That one you can probably feel. The diaphragm then moves up and regains its shape. Again, you probably don't feel your diaphragm moving, but you can feel the ribs. So when you breathe out, they go down and in. The diaphragm regains its shape. Oh, so what's happened to the volume? Ribs are in, diaphragm up. The volume here is smaller. Oh, Boyle's Law, a smaller volume means higher pressure. So for higher pressure, to equalize that, air is forced out. So very simple mechanisms. We do that all the time without even having to think about it. Your body's breathing in, breathing out. Boyle's Law, equalizing pressure. Here's my word, fascinating. And again, that's a little diagram that just talks about the ribs, the diaphragm, the chest volume movement. But like I said, if you breathe in and out, you should be able to feel that. There's a video that I'd like you to watch just to help explain some of the things we're talking about. And that's it for this lesson. So your homework assignment today is 8-1, the anatomy of the respiratory system. Again, that fill in the blank sheet is basically our system. It takes you from the beginning to the end and talks about the structures, the functions, the overall system. And our joke of the day: I have had a terribly, horribly busy day converting oxygen to carbon dioxide. Now I need a moment just to breathe. Haha, that's clever. Okay, so good luck with 8-1. And like I said, it's a nice, short, simple unit. So have fun. Bye.